Hey everyone, Mr. Fransky here. We're going to continue kind of our unit circle graphing unit here with 4.5, where we're going to graph tangent, cotangent, secant, and cosecant. So we've graphed sine and cosine. Sine starts at 0, right? Cosine starts at 1. So now we're going to kind of graph these other functions we've talked about on the unit circle, and some of them are actually very closely related to sine and cosine. The secant and cosecant functions are just reciprocals of these, so they're pretty easy to figure out. So we've also talked about on the sinusoid packet how it's important to know negative sine starts at 0 and goes down, and negative cosine starts at -1 and goes up. So it's kind of like, are you given a low point, a high point, or a midpoint, and you go up or down, and which kind of function are you looking at, right? So let's jump in here. So first of all, tangent x. So let's think about the unit circle. So we're going to graph tangent just like we do the others. So at 0, tangent is 0. Then as you increase, because of that tangent line, tangent gets bigger and bigger and bigger without bound. And there's a asymptote at pi over 2. So at pi over 2, we have a vertical asymptote. And we get bigger and bigger and bigger. So it looks something like that. Then right after we cross over pi over 2, we have giant values, but they are negative, right? Because in the second quadrant over here, cosine is negative, while sine is positive. So we have negative values down here, and they increase up, right? Because we have negative values, they're getting closer to 0, and then we hit 0 when we get to pi. So at pi, we're right at 0. Maybe write that pi over 2 a little better. Okay, so we have an asymptote. So we start very negative values, and we come up to pi. After you go through pi, the third quadrant has positive values, and they're getting big again. So do something like that. And then we have another asymptote at 3 pi over 2. Okay. So then we are going to come up again. It's going to keep doing this. Okay. So tangent kind of makes these like little lane change kind of things. They kind of look like cubics, except cubics don't have asymptotes, right? They keep going to the left, even though it looks like they go flat. Okay, so this is our tan x, so f of x equals tan x. Okay, it makes these kind of swoop things. It has asymptotes every pi over 2. At the pi over 2s, it has zeros every pi. So a little bit of info about tan x. So function looks like this. This is pi, this is 0, this is pi over 2. Next one's 3 pi over 2. So the period of this guy is not 2 pi. The period of this guy repeats itself every pi, right? If you just kind of chop this section out from here to here, that length is pi. So the period is pi. Tangent doesn't really have an amplitude. So if you're ever asked for an amplitude on this, I would just write not applicable. So NA, something like that, because there is no amplitude for tangent, right? It's not a wave function. It's periodic, but it's not a wave. This is an odd function. Okay, because if you just focus on this one right here, if you spin it around, this arrow right here is going to go down to this arrow right here. It's rotationally symmetric. But if you think about it more, I mean, this guy over here is going to translate over to this guy over here when you rotate it around. So it's an odd function. Domain. Domain is all real numbers except all those asymptotes. So those are odd pi over 2s. Okay, right? 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. The fancy way of writing that is pi over 2 times 2n plus 1, where n is an integer. Remember z, we learned that on the first day of class. So n is an integer. If you take any integer and multiply by 2, that'll make it an even number. Then you add 1, that'll make it an odd number. Right? So if n is -5, then this would be -10 plus 1 is -9. If n is 7, 14 plus 1 is 15. This will be every odd number. I think that was all I wanted to say about tangent. Let me just double check. Okay. Oh, the range. Range is all real numbers, right? You can get everything from negative infinity to infinity. And that makes sense to me on the circle, because you can make tangent as big as you want. The closer you get to pi over 2, the longer that tangent line is going to be. Cool. Now let's talk about cotangent. So cotangent, a little bit weirder. We have those cotangent lines, right? So cotangent starts right off the bat being undefined. So we have an asymptote right at 0, because we have parallel lines. Then it starts off very, very big, right? Because just when we just start off, it's going to be very long numbers. So it's going to start super high up, and then it's going to decrease down to 0 at pi over 2. So something like this. So here's pi over 2. And then it's going to keep decreasing, because we become negative in the second quadrant, until we get undefined at pi. So pi is a vertical asymptote. And just like tangent, then it kind of continues on, right? Every pi, so at 2 pi, there's going to be an asymptote, right? We have a 0 here at 3 pi over 2. Okay. And on the left side, same thing. Interesting thing about this, also an odd function, even though it doesn't go through the asymptote, or through 0, 0. If you rotate this guy around to the other side, this arrow here would match down to this arrow down here. This arrow would come up to here. Definitely still an odd function. So let's write down some info about cotangent. So cotangent looks like this. Period is still pi. No amplitude, right? Because it's not a wave function. So I'm write NA on that one. This is pi over 2. This is 3 pi over 2. This is pi. This is 2 pi. 0. Okay, so the domain of this guy is all real numbers, except this time it's all the pi's, right? 1 pi, 2 pi, 3 pi, so n pi. Okay, so 1 pi, 2 pi, n pi, not pi, pi. N pi, where n is an element of the integers. Okay, so all, like 0 included, right? 0 pi would be right here. So we have those asymptotes. Range is all real numbers. And this is also an odd function. Weird that it's an odd function, but every one of these is going to have one on the other side of 0, 0 when it rotates around. Okay, so see, tangent, cotangent have these kind of lane change things going on. Secant and cosecant. All right, so let's first think about this from the circle. So secant starts off at a value of 1, right? It's the length of this line right here. So it starts off at a value of 1. So that's 1 right there. And then it starts getting bigger and bigger and bigger until we hit an asymptote at pi over 2. So it's going to go up kind of like that. Okay. Then right on the other side of pi over 2, we have very big numbers. So if we're doing secant here, secant is, remember, 1 over cosine. So now we go to very negative numbers because we're using that tangent line. So we have very big numbers and they're negative. So it's going to be down here. The smallest it gets is negative 1 right there. Okay, so it'll be something like this. Okay. And then we start to get bigger again, but we still have negative values. So we get super big, so we're going to have another asymptote at 3 pi over 2. This was pi right here. So we go down like that. All right, and then we have positive very big values. It's going to come down to 1 at 2 pi. And then it's going to go up again. So we kind of create these U's. People often say they're parabolas. They're not parabolas because parabolas don't have asymptotes. But it's going to create this periodic thing with these U's. Okay. You might have guessed cosecant looks similar. Cosecant just uses the cotangent lines. So cosecant starts off undefined. So this is secant x. This is cosecant x. So cosecant starts undefined. And then immediately right out of the gate, we have very big positive numbers. So it's going to start up here. It's going to come down to 1 because at pi over 2, we have that value of 1. Then it's going to go up again, right? Because sine is still positive on this side. And then we become undefined, and then we go negative. So we have a U like this, and that's at 2 pi. And this pattern continues up here, down here. Okay. But one of the coolest things about this is if you graph in the reciprocal, a different color for that, maybe red. So if you graph in like cosine on this guy, so remember secant is 1 over cosine. Cosine would have a 1 here, a negative 1 here, a 0 here. And it kind of just like sits inside of those U's, right? So it touches at the 1s, and it has 0s at the asymptotes, which makes sense because secant is 1 over cosine, right? So whenever cosine is 0, that's when you have the asymptotes. Same with sine, right? Sine starts at 0, which is why there's an asymptote for cosecant. And it kind of does one of these. Right? So it's going to touch at the bumps at each of those U's. And then when sine gets very close to 0, it makes sense that cosecant's going to freak out. Because when sine is close to 0, the value of 1 over sine is going to be very, very big. So how do you graph these things? If you want to have it transformed like a sinusoid for a cosecant, all you have to deal with is first you're going to graph sine or cosine. Okay, so you graph the transform sine or cosine wave. So let's say you have initially sine, and then you're dealing with cosecant that has been moved somehow, so you regraph your center, you moved over here maybe it's really big now, okay? And then all you do is put the asymptotes where the zeros are. So asymptotes at the zeros. Remember, they're not really zeros, right? They're zeros on the new center line, okay? So asymptotes at the zeros, and then you put the bumps to touch where you have the maxes and mins. Right, so you make the bumps touch there and touch there. Now, technically, the sine wave itself is not really part of the graph, right? So you can erase it, or sometimes people put it as a dotted line. But the important thing is just it's not part of your actual graph. I know it's not. So if you graph it in there, I'm going to know that it's just the U's that you want. But a dotted line or erasing it is kind of a good idea. Right. So you touch at the bumps, you have the asymptotes at the zeros, and that's really going to be it. Period for these guys, period for both of these is 2 pi. Right. The asymptotes for this guy happen at 2n plus 1, so we get the odds, pi over 2. These guys happen at n pi. Again, these really don't have amplitude, but if you tell me the amplitude for this guy is 1, and for this guy is also 1, I'll understand what you mean. That's the amplitude of the sine and cosine wave, and then that's like where the bumps touch for secant and cosecant. Alright, so that's kind of the skinny on how to graph these things. Let's do some examples. So first we're just going to start with a cosine. We've been talking about this a little bit in class. It's on your sinusoids packet, but I want to start with just a simple one so we can kind of get into the tangent, cotangent, secant, cosecant next. So first thing I'm going to do is I'm going to clean the x, right? Because we have to have this look like b times x minus h. So I'll pull the 2 out. So I have 3 cosine of 2 parentheses x minus pi over 2. How do I get pi over 2? Well, I have to multiply 2 by something to make pi. The 2's will now cancel. If you have trouble with that, put an x there, or any letter you want. H. H is good. So now I know that 2 times h has to be equal to pi, because that has to be what I get as a result. Just divide by 2. So h is pi over 2. Now I erase the h, put a pi over 2 there. That's harder when it's like, you have like 1/2 x minus like pi over 8, something like that, right? So when you pull the 1/2 out, it's like x minus, well, what the heck goes here? It ends up being pi over 4, right? But it might take some thinking to do that. You might have to do this little scratch work over here that I have on the side. Okay. So now our x is clean, plus 1. So now what we're going to do is we're going to make our table. So x, we're starting out with cosine x. Alright, so 0, pi over 2, pi, 3 pi over 2, and 2 pi. Cosine starts at 1, down to 0, negative 1, 0, and 1, right? Starts at the top, goes down, and comes back up. So now we'll do our scale change first. So the scale change, we're going to have x over 2, and we're going to have 3y, right? Because the x does the opposite of what you want, and the y does what you expect it to. So 3y is easy. 3, 0, negative 3, 0, 3. So we haven't moved our center line yet. Remember, we always do this RST, and I always do the R and the S together. If there's a negative, you do the negative now. But we don't have a negative in front or in front of the x, so we don't have to deal with that. X over 2, let's see. So we have 0, pi over 4, pi over 2, and then 3 pi over 4, and pi. So right there we see our period is pi. Right? Before it took us 2 pi to do it, now we do it all in pi. And now we're going to do our translation. So we have x over 2 plus pi over 2, right? Because it's the opposite of what we want. So we're going to add pi over 2 to all these. And then our y is going to be 3y, and we're going to add 1 to them. So let's do the y's first. So we have 4, 1, negative 2, 1, 4. So it looks like our new center line is at 1 now. So we're going to add pi over 2 to all these. 0 plus pi over 2, pi over 2. Pi over 4 plus pi over 2. Well, pi over 4 plus pi over 2. This is 2 pi over 4, so I have 3 pi over 4. Pi over 2 plus another pi over 2 is pi. 3 pi over 4 plus pi over 2, that's 3 plus, so we have this 2 pi over 4, so that's going to be 5 pi over 4. It takes some practice, but you'll get better at it. Pi plus pi over 2, that's 2 pi plus 1 more is 3 pi over 2. So from pi over 2 to 3 pi over 2, we haven't changed our period. That's still a distance of pi, right? That's top of the circle to the bottom. And now we graph. So we're starting at pi over 2, and we're starting at 1. Okay, we have to go up to 4, down to negative 2. Okay, so at 3 pi over 4, we start at 4. Because cosine starts at pi. So at 3 pi over 4, we're at 1. At pi, we're at negative 2. At 5 pi over 4, we're at 1. And then at 3 pi over 2, we're at 4. So, yeah, a cosine function like this. Some people make straight lines for these. Don't do that, right? Cosine is a curving function, right? Don't just do like straight line, okay? So cosine is a function that curves, so you have to make sure that we curve down and curve back up. Now this will continue, right? But all I want you to do is be able to graph one period. But it will continue this way. It'll continue this way. Okay. Cool. Let's try one with, let's see, tangent. Okay, so we have x, we have tan x. So make our chart here. So we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. This is a less exciting chart because tangent of 0 is 0, pi over 2 is undefined. Pi, we're back to 0. 3 pi over 2, we're back to undefined. And 2 pi, we are back to 0. Okay, because tangent looks like this, right? So 0 is right here, then we're undefined, then we're at 0, then we're undefined, but it still works. We're going to be able to see where our asymptotes go. So first we scale change. So we have x over 2, and we have 2 tan x. Negative 2 tan x. Negative 2y, I should write, sorry. This is y. Now, what you notice about the y's is they don't really do anything, because if you stretch this function, yes, these points are going to end up moving, right? They're going to move up. But the asymptotes don't move, and really it's the general shape of the function we want. So we're going to have still 0, undefined, 0, undefined, and 0. The x's are the important part. So 0, pi over 4 now, pi over 2, 3 pi over 4, and pi. So our period now, remember, normal period for tangent is pi, so it's now pi over 2. And actually there's no shift at all for this. So that's it, we're done. Let's see here. So at 0, we're still at 0. Now at pi over 4 is when we have our asymptote. So it's going to be a little skinnier tangent. And then at pi over 2, we have our 0 again. And then at 3 pi over 4, we're undefined. And that's good enough. Really, I just need one full period. So that's good. All right. Try one with cosecant. So first thing I'm going to do is clean that ugly x. So we got 1/2 cosecant pi times x plus 1 minus 2. Alright, so let's see what we got here. So we start with x. What are we graphing first? We're graphing sine. Sine x, because cosecant is 1 over sine. So we have 0, pi over 2, pi, 3 pi over 2, 2 pi. So sine, because remember it's going to be, we're going to graph sine, then we're going to graph the bumps in where they belong, right? Alright, so at 0, sine is 0, then we go up to 1, then to 0, then to negative 1, then to 0. Got to know that cold, like the back of your hand. So now we're going to do RST. Doesn't look like there's any reflections, but we do have some scale changes. So we're going to have, let's see, x over pi. Interesting. So we're not going to have like pi's in our answer. It's going to be normal numbers. That's nice. And then our y's, looks like we have 1/2 y. Alright, so x over pi. 0, pi over 2 over pi. The pi's cancel, right? That's the same as pi over 2 times 1 over pi. Pi's just cancel out, so it's 1/2. Pi over pi is 1. 3 pi over 2 pi over pi is 3/2. So then 1/2, 1, 1.5, and then 2 pi over pi is 2. Half of y, 0, 1/2, 0, negative 1/2, 0. Alright, now we translate. So we're going to do x over pi. We're going to take that. We are going to add 1, or subtract 1 from it. Thank you. Alright, and then 1/2 y. We're going to take that and subtract 2. So 0 minus 2, negative 2. Half minus 2 is negative 3/2. 0 minus 2, back to negative 2. Negative 1/2 minus 2 is negative 2.5, or negative 5/2. And 0 minus 2, negative 2. So center line is at negative 2 now. So 0 minus 1, negative 1. 1/2 minus 1, negative 1/2. 1 minus 1 is 0. 3/2 minus 1 is 1/2. 2 minus 1 is 1. So let's graph it. So we start at -1, so that's got to be on the left side. So we got -1, we got -1/2, we got 0, we got 1/2, and we got 1. So we complete the whole thing. It looks like the period of this thing is 2 now, which makes sense because that's 2 pi divided by pi, which is 2. Okay, so we start at -2. We're going to run into my numbers here, but that's okay. So start at -2. And then we go to -3/2. So that's these numbers. So we got -1 here, -1/2 here, 1/2 here, and 1 here. So our whole thing's going to be underneath the graph, so I move the numbers. So we start at -2, then at -1/2, we're at -3/2. It's -1/2, it's right there. So a very shallow sine wave here. Then we go at 0 to -2, and at 1/2 we're at -2.5, which is right here. And then at 1 we're back to -2. Now I'm going to make this dotted. Why? Because this is not the function I want to graph, right? I want to graph cosecant. So we have vertical asymptotes whenever we hit the 0 on that center line. So that's going to be at -1, 0, and 1, it looks like. And then we just make it touch the bump. So I'm going to do this in a different color. Let's do it in red. So this is the actual cosecant function. Touches at the bump there, touches at the bump here. That's all there is to it. Okay, so that's really all there is to graphing these things. They're not super easy, but not super hard. Go back and watch those examples again if you need to. Love you guys. That's why I'm here. Have a great day.